So this is just going to be a quick little video on basically on how to set up the first step of the partial fraction problems. I think people have a lot of trouble getting their head around this piece right here and what this means and how to set it up in terms of problems. So I think maybe 7 or 8 examples here that I'm not going to solve them. I'm just going to set them up so that you can kind of see how that first step goes. Because I think then you get so bogged down in the solve that you never get into a good flow on this first step. So this first one, everything's linear. Everything is to the first. So that would be, and nothing is repeated, right? None of these are the same. So that's an example of this first one. And so this is just going to set up a over x, b over x plus 3, and c over x minus 1. And it doesn't matter which one got a and which got b and c, because it just, when we write down the answer, the right numbers are going to be above the letters. So which letter goes with which thing, not a big deal. Okay, so this next example is repeated linear factors. So I have x plus 1, which is linear, and then that factor is repeated 3 times. So it looks like a cubic, and if this were squared, you'd think it looks like a quadratic. But it's not x squared, it's the quantity squared, it's that multiplicity. So that's where we're going to get the repeated roots. So even though this feels like a cubic, it's linear because the inside piece is linear. If this had a 3, then we'd be thinking that's a cubic. So out here we're going to get a, and then x plus 1, and then b, and what we have to do is set up for every possible iteration of this. So x plus 1 squared, and c, x plus 1 cubed. So that's an example of this one. And so if I have x plus 1 quantity cubed, I could have had a term that was just x plus 1. I could have also had a term that's x plus 1 squared. I don't know till I solve. These could come up to numbers, or one could end up being a 0. And then that would just be mean that term wasn't necessary. So we have to allow for all the possibilities. So this one at the moment is a cubic, and this is where we see if we can break it down to either linear or quadratic terms, because those are the two we know how to do. So I can take an x out of there. That's going to be x squared plus 8x plus 16. And then this is going to be x plus 4, but I want to think of that as x plus 4 squared, right? So let me rewrite it up here, x plus 4 squared. Because there's that repeated linear root again, and this is what I'm saying, this is to the first, so that makes it linear. When I hit a quadratic one, you'll see this is to the second. So it's not the multiplicity, it's whether or not the x itself is to the first or to the second. So this would be a over x, so there's my first linear term, and then it'll be b over x plus 4, and then c over x plus 4 squared. So that would be your setup. And of course, all of these require like a page to actually solve them, right? But I'm just trying to get you that first step so you can kind of see how that goes. Okay, so then what about this x squared? Is it quadratic or is it linear? Well, it's linear because it could be broken down to x times x. So this is going to be a over x plus b over x squared plus c over x plus 2. And this x plus 2 to the first, so it's just getting a c. Okay, for this next one, we're going to take out an x, because that's our common factor. It's going to leave an x squared plus 5. So let me rewrite that here. So that is an actual quadratic now, and that's because this one, I can't break this up at all, right? X squared plus 5, it's prime. It's to the first, so it's not a repeated quadratic, but it is a quadratic. So this is going to set up a over x, and then finally for the quadratic, we need our bx plus c over x squared plus 5. And so there's a non-repeated irreducible quadratic factor. That's what that one is. This next one's the same thing. It's just kind of sitting here looking at us this time. So because the square is on the inside, that makes it quadratic. So this is ax plus b, x squared plus 6 plus c, x minus 3. So this example, the x is just a linear. So a over x. This time it's repeated because it's squared, irreducible quadratic. X squared plus 4 doesn't factor. So this is going to be ax plus b over x squared plus 4, and then plus cx plus d over x squared plus 4 squared. Here, then this one does factor, so we have to do a little bit of work. So I'll go this way with it and bring it down below. So this would be, let's see, this is going to be 1 over x squared minus 4. But then here we got to be careful to not stop, because this one does keep going. So while this is quadratic, it's reducible, which means it's not like this that was irreducible. So this would be x plus 2, x minus 2. Oops. And then that's just a bunch of linear terms. So then that would equal a over x plus b over x plus 2 plus c over x minus 2. Hopefully that helps you kind of get the flow for how to set these up.